Assalamualaikum and I hope you had a good day today. My name is Sayang Alia Prazana and my metric number is CF210297. I'm from Group 3 Section 5 and today I'm going to introduce our group member which is Jonathan Tan Jit Leong CF210052, Isaac Alan Sigar CF210330, Javitan Nair CF210031 and lastly Shaza Shazwani binti Muhammad Ali CF210110. And next, we're moving on to the next part.
Firstly, I would like to introduce our introduction of our project. So our project consists of 5 different elements of civil engineering structure such as roof, cantilever slab, beam, short span bridge, column and beam were found for this project. The structure was studied and determined by analyzing the free body diagram, loading, support, centroid, and the moment of inertia. Each of the structure on the site were recorded through picture, their material use, their function, their location, and their measurement.
Hi, my name is Isaac, so I will try to explain on our group problem statement. And our group have listed 6 problem statements which will we interpret into our group report. And the first problem statement that we have stated is how to find and introduce a suitable structure for each structure element such as the material use, function, measurement, and the location. And the second problem statement is how to draw the free body diagram of the structure. The third problem statement is what are the action and loading that may occur on the structure. And the fourth problem statement is how to describe the support reaction of the structure. And the fifth one is how to find the centroid of the structure. And the sixth problem statement that we have listed is how to describe the moment of inertia of the structure.
My name is Dayang Alia Farzana and my metric number is CF210297 and today I'm going to talk about objective, which is the first is to be able to introduce a suitable structure for each structure element such as material use, function, measurement, and location, and to draw the free body diagram of this structure. Moreover, to estimate all of the actions and loading that may occur on the structure, and to describe all support reactions that occur in this structure, also to find the centroid, and lastly, to describe the moment of inertia. There are 5 elements of our structure, which is roof, cantilever slab, beam, column, and lastly, short span bridge. Hello, we'll be moving to roof introduction, which is a roof is a layer of building's outer covering that serve a variety of purposes. For starters, it protects the open or closed space beneath it from the elements. The most significant components here are successfully draining precipitation, giving protection from the sun and wind, and offering insulation. Based on the functional requirements or the wind approach, many structures might be employed. The roof is subjected to a variety of forces that must be either be carried directly to the ground or through outside walls, columns, or foundation. Different buildings and roof types are distinguished. The selection of an appropriate roof is influenced by a number of elements. The most crucial criterion is probably appearance. Then there's the plan views, configuration, and size, which is influenced by construction costs and applicable building codes. The importance of knowing the uses of roof in home structures, and in this chapter, it also can determine how much torque an object requires to achieve a given angular acceleration when calculating rotational force, and how to determine the force inside the roof structure. This is our free body diagram, and also this is our support reaction for our elements, and also we have the calculation for our. And as for the center of gravity, we have height times width line, which is 26 cm over 26 cm. And as for the result of x-axis, it's 16.83 meter, and for the y-axis, we get 8.67 meter. For the moment of inertia, we get the x-axis for 12693.7 and for the power of 4, And for the y-axis, we get 55991.94 for the power of 4. So this is the result of our moment of inertia for the roof. As for the conclusion, static is a critical factor to consider before beginning construction work on a building on the job site. The triangle or a set of triangles is the engineering basis underlying the truss. A triangle is particularly robust in geometry and can sustain various weight better than other forms. The number for the support reaction, centroid, and moment of inertia have been all computed, and they are all quite rational, correct, and sensible. Based on the estimate calculation, this structure may be considered sturdy and robust, and the material used in its construction is acceptable for dwelling construction.
The second structure was a cantilever beam. A cantilever is a beam that has one fixed end and one free end. It is usually mounted horizontally to a vertical wall and let to bend under its own weight in the most practical application. It was a beam with a uniform distributed load that has one fixed end and one free end. The structure or building is a double-story terrace corner house that located at the Jalan Matang, Batu Kawah, Kuching, Sarawak. The material used for this structure is a cement. Next, I'm going to present the free body diagram of the structure. As you can see, the figure showing the free body diagram being drawn. So, the beam consists of 4 meter long, being times by a 20 kilometer per meter. So, we get a uniform distribution load of 80 kilonewton. The support reaction of the structure at moment A, as we can see on the slide, after being calculated, all we get is 160 kilo. For the centroid of the structure, it was calculated as in the slide. So for the x-axis, all I get is 1.36, and for the y-axis, all I get is 2.4. And lastly, the moment of inertia of the structure was found. So after being calculated, the moment of inertia at x-axis was 74.01 meter to the power of 4, and the moment of inertia at axis y was 23.31 meter to the power of 4.
Hi, my name is Nathan and I will continue the presentation. I will present about beam. Beam structure is a type of structure used in construction and engineering to provide a safe and efficient load path that efficiently distribute weight throughout the foundation of a building. For the selection of the beam for this project is a fixed beam with uniform distribution load. A fixed beam is one that has support on both ends of the beam. Location of the beam is at Lot 50, Kampong Sepon Ulu, 94600 Asajaya, Sarawak. And the material of the beam is cement, and the type of the beam is fixed beam with UDL, uniform distribution load. As you can see in the slide, there is a free body diagram that has been drawn, and this slide is about estimation of loading. The mass of the load is 26 kN per meter, and the length of the beam is 5 meter. And so the magnitude of the beam is 130 kN. Simply support beam with a point load is 130 kN at the middle, but the support direction is 65 kN at the both sides. And in this slide, we will present about the centroid and the moment of inertia. In the centroid is 0.625, as you can see in the calculation, and based on the calculation of moment of inertia on x and x-axis is 0.052, and y-axis is 5.21. So conclusively, this beam structure is considered as safe and strong.
My name is Jivitan Nair, metric number CF210031. The structure that I would like to present is about column and beam. For the frame structures, those are the structures having the combination of beam, column and slab to resist the lateral and gravity loads. These structures are usually used to overcome the large moments developing due to the applied loading frame if structures have economical design. Columns are structural vertical elements where the load is transmitted as compression and often as friction. parallel to the longitudinal axis. Columns are used for support of floor or roof beams and the above floor column. The location of my beam is around new houses at Casa Garden, Cyber South 62050, Putrajaya, Selangor, Malaysia. Next, I will be presenting about the free body diagram. As you can see the diagram, the concentrated load is 4 kilonewton and the length of the beam is 5 meters and the height is 5 meters. And as you can see, the SFD and BMD diagram is shown. The support reactions that we got for the simply supported pinned was RA, we got 15 kilonewton, and for the RB, which is roller, we got 10 kilonewton. Next, moving on to the centroid of the structure. For the centroid of x-axis, we've gotten 4.57 meter, and centroid of the y-axis, we've gotten 2.07 meter. Then for the moment of inertia, for the x-axis, we've gotten 1528.4 meter power of 4. Then for the y-axis, we've gotten 339.4 meter power of 4.
Now I will continue to our next structure, which is short span bridge. So short span bridge are commonly found in the pedestrian area, which is help to connect between two short distance that can be accessed by a land transportation. And short span bridge are different than the other type of bridge. They have no built-in support. The only support are provided by pier. And the structure of this short span bridge that I've chosen is located at Sungai Adong Baram, Miri, Sarawak, and the material that I use are cement, and to cover up the cement above is asphalt. This is the idealization of the structure. As you can see here, the length of the short span bridge that I have chose is 18 meter. Which is supported by 2 piers, and the height of the piers is 3 meter, and the width of it is 1 meter. Above the piers there is a slab with a thickness of 0.5 meter, and a guardrail along the bridge with the height of 1.5 meter. And I have interpreted into a free body diagram, and I have determined that there is 2 types of support that have on this bridge, which is pin support at point A and roller support at point B. Now we will go through to the estimation of the load on the short span bridge, and the mass of that load on the short span bridge is 4,000 kilogram, and the mass of the beam itself is 12,000 kilogram. And after we convert it into weight, and then we have found out that the weight of the dead load is 39.24 kilonewton, and for the weight of the beam is 117.72 kilonewton. So the total loading act on this beam is 824.04 kilonewton. And after we found out the total loading act on the beam, and we will distribute the load, and the total loading act will be divided by the length of the bridge, and we will get 45.78 kilonewton per meter. So now we will go through the support reaction that act on the beam, and as I explained just now, at point A was used pin support, so the support reaction is from the beneath and from the beside of the beam, and for point B is roller support, and the support reaction is from the beneath. And after we calculate it, support reaction at point A we will get 412.02 kilonewton, and at point B we will get 257.51 kilonewton. Now we will go through the centroid of the area. So I have divided it into 4 parts of composite shape, and you can see that first part is the pier, and the second part is the pier at point B, and the third part is the beam itself, and the fourth part is the guardrail itself. And after we calculate the centroid of each area and summarize it into x-axis and y-axis, and the centroid for x-axis, you can see it was located at 9 meter, and the location for centroid for y-axis is at 3.64 meter. So now we will go through to the moment of inertia that act on the bridge, and as you can see, the moment of inertia about x-axis after we calculate, we will get 48.651, and the next one is the moment of inertia about y-axis after we calculate, we will get 1406, and we can see that the structure is considered as a strong structure for the vehicle to pass by.
So, the conclusion of the project is every structure is strong and safe and have their own purpose and function in the construction. Roof, beam, column, slab, and short span bridge structure are integral part of a construction and are among the most important elements in the construction. It is important to learn and study about the structural framework of a building structure. That's all from us, Group 3. Thank you.